A limitation of the reals. A linear equation has the form ax plus b equals 0, where a is not equal to 0. If we are working inside a field, then this equation has the unique solution x equals negative b a inverse, or equivalently x equals negative b over a. Write a times negative b over a plus b is negative b plus b, which is 0. Let's look at a specific example. Inside a field, the equation 2x minus 1 equals 0 has the unique solution x equals 2 inverse, or equivalently x equals 1 half. It is important that we are working inside a field here. If we were allowed to use only the properties of a commutative ring, then we might not be able to solve this equation. For example, in Z, the ring of integers, the equation 2x minus 1 equals 0 has no solution. Indeed, this equation is equivalent to the equation 2x equals 1, and 2 does not have a multiplicative inverse in the ring of integers. A quadratic equation has the form ax squared plus bx plus c equals 0, where a is not equal to 0. Is working inside a field enough to solve this equation? The answer is no. Let's look at a couple of examples. The equation x squared minus 2 equals 0 is equivalent to the equation x squared equals 2. In lesson 5, we saw that there is no solution to this equation in Q, the field of rational numbers. There's no rational number whose square is equal to 2. This was our primary motivation for introducing R, the field of real numbers. And in fact, the equation x squared minus 2 equals 0 can be solved in R, in the field of real numbers. The equation x squared plus 1 equals 0, however, cannot be solved in R. After all, this equation is equivalent to the equation x squared equals negative 1. And we saw in lesson 6 that for any real number x, x squared, which is an abbreviation for x times x, can never be negative. Is there a field containing R where all quadratic equations can be solved? The answer is yes. In fact, there is a field containing R, namely the field of complex numbers, such that all polynomial equations can be solved. By a polynomial equation, we mean one of the form a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a1x plus a0 equals 0. For example, if a1 is the first non-zero term, we get a linear equation. If a2 is the first non-zero term, we get a quadratic equation. But polynomial equations can be much longer than linear or quadratic equations. Such a field in which all polynomial equations can be solved is called an algebraically closed field. Although we're not going to show that in this lesson, it is true that the field of complex numbers is an example of an algebraically closed field.